Proxima b, orbiting the closest star to our solar system, has long captured the imagination of scientists and dreamers alike. Its mysterious nature and unique position have intrigued researchers since its discovery. Being located in the Alpha Centauri system, only 4.24 light-years away, Proxima b is the closest exoplanet to Earth that is within the habitable zone where liquid water could exist. The scientific community has been focused on the potential for life there, wondering if the planet could host conditions suitable for organisms similar to those on Earth. However, its dark side, which was hidden in shadow, remained elusive and largely unexplored until recently, when the James Webb Space Telescope was able to provide groundbreaking data. These discoveries have sparked renewed excitement, as the planet could hold answers to many questions about planetary habitability and extraterrestrial life. But while its illuminated side has been a topic of intense study, its dark side, permanently locked in shadow, remained an enigma, until now. The dark side of Proxima b, a region that faces away from the star, has long been considered an area of great mystery. Scientists assumed that the constant lack of sunlight would lead to an environment inhospitable to life, resulting in extreme cold and frozen conditions. However, this assumption has been turned on its head after recent observations. The James Webb Space Telescope's findings challenge this view, offering new clues that suggest something far more complex and fascinating may exist on this side of the planet. The dark side's unknown nature has intrigued astronomers, and now the information being gathered could change our understanding of planetary climates, habitability, and even the potential for life in the most unlikely of environments. The James Webb Space Telescope has finally unveiled the secrets of this mysterious region, revealing data that has left scientists both amazed and bewildered. The findings from the Webb telescope represent a significant leap forward in space exploration, as this advanced instrument was designed to capture infrared light, which is crucial for observing distant and obscured regions of space. Through its infrared capabilities, the telescope detected faint emissions from Proxima b's dark side that cannot be explained by natural processes known to science. These unexpected signals are unlike anything seen before, prompting scientists to reconsider what might be occurring on the planet. The data has left the scientific community both astonished and eager to investigate further, as the implications of these findings could dramatically change our approach to studying exoplanets, especially those with extreme and hostile environments. These revelations have opened up new avenues of research, where the unknown could hold the key to understanding life beyond Earth. With one side perpetually bathed in sunlight and the other frozen in eternal darkness, the dark side was assumed to be lifeless and barren. Scientists believed that the perpetual shadow facing the planet would result in a cold, inhospitable environment, incapable of supporting life or any significant atmospheric activity. The idea of a barren world was solidified by the fact that many tidally locked planets, those that always show the same face to their star, experience drastic temperature gradients between the illuminated and dark side. While the sunny side could have temperatures that support life, the dark side was thought to be frozen, devoid of warmth, light, or activity. This assumption made it a target of little interest compared to the more studied illuminated side. However, the new data has forced scientists to revisit these assumptions, with evidence pointing toward unusual and unexplained phenomena in the planet's shadowed region, suggesting that it may be much more than a lifeless wasteland. However, recently declassified images tell a story no one expected. The release of these new images has brought about a paradigm shift in our understanding of Proxima b's dark side. What was once considered a cold, uninhabitable region now appears to be a dynamic environment with unique features and unexplained signals. These images, captured by the James Webb Space Telescope, suggest that there may be hidden sources of heat and energy within the dark side of the planet. The unusual emissions detected from this area challenge previously held beliefs about how tidally locked planets behave. The data from these images have generated intense excitement in the scientific community, as researchers have begun to consider the possibility that the dark side of Proxima b might harbor conditions capable of supporting life, or at least some form of active processes that could change our understanding of such planets. The first clues came in the form of unexpected emissions detected from the dark side of Proxima b. The discovery of these faint emissions was the first sign that something unusual was occurring on Proxima b's dark side. These emissions are highly intriguing because they do not align with what we would expect from a planet with a permanent night. In the absence of sunlight, any form of natural light or heat should be minimal or non-existent. Yet these signals, although faint, have been detected consistently, raising questions about their origin. Infrared radiation is typically emitted by warm objects, so the presence of such emissions on the dark side suggests that there may be localized heat sources, possibly from volcanic or geothermal activity. The regularity and persistence of these emissions have led to speculation that the dark side of Proxima b may be more than just an empty frozen landscape and may instead be home to active geological processes, or even some form of energy generation. These signals, faint yet persistent, challenge our understanding of planetary environments. What makes these emissions particularly puzzling is their persistence in a traditionally dark, frozen environment. Signals like these should not exist unless some kind of energy source is at work. This persistent emission pattern has challenged planetary scientists, who would have expected a much colder and more static environment. The emission signals suggest that Proxima b's dark side is not simply an inert or inactive region of the planet. Instead, these faint but consistent signals may indicate ongoing processes, whether geological or even biological, that are defying expectations. The challenge to conventional thinking in planetary science comes from the fact that such emissions have been observed from the dark side of a tidally locked planet, where no sunlight reaches. Understanding the origins of these emissions could unlock new knowledge about planetary dynamics and the potential for habitability in extreme environments. Infrared radiation and unique energy patterns suggest localized sources of heat and light, phenomena that are not consistent with the planet's known conditions. The detection of infrared radiation on Proxima b's dark side suggests that there are localized sources of heat, which is unexpected given the planet's extreme distance from its star. These energy patterns are unlike anything typically seen on planets with such harsh conditions. What is particularly interesting is that these patterns suggest that there may be pockets or regions on the dark side of Proxima b that have their own independent sources of heat and light, which are not attributable to sunlight or the star itself. The idea that a planet's dark side could harbor these kinds of phenomena pushes the boundaries of our understanding of exoplanets and planetary environments. This discovery has opened up exciting possibilities, including the idea that Proxima b may have some form of active internal processes, possibly geological, that generate the necessary heat to support life or other phenomena on its dark side. Could these emissions be natural, or do they point to something more extraordinary? One of the key questions raised by the discovery of these emissions is whether they are a natural occurrence or the result of something more remarkable. While natural sources such as volcanic activity or geothermal heat could explain some of the signals, the regularity and unique patterns of the emissions have led many to consider the possibility that they may be artificially generated. The idea that Proxima b might host an advanced civilization capable of producing these emissions has captivated the imagination of scientists and the public alike. It's a tantalizing possibility that we may be witnessing the first hints of extraterrestrial technology or even evidence of intelligent life. Whether the emissions are the product of natural geological processes or something far more extraordinary, they have sparked a wave of speculation and curiosity about what might be lurking on this mysterious planet. The irregularity and structure of these signals have led some experts to consider the possibility of artificial origins. The The structure and regularity of the signals emitted from Proxima B's dark side have intrigued many experts, prompting some to entertain the idea that they may be artificial in origin. The emissions are not random or sporadic but show a distinct pattern, suggesting some level of organization. This has led scientists to entertain the possibility that they are the result of technology or purposeful activity rather than natural phenomena. The detection of structured signals from such a distant and extreme environment raises profound questions about the existence of advanced civilizations capable of thriving in conditions we would have previously thought impossible. Could Proxima B's dark side be hiding evidence of intelligent life or advanced technology, perhaps a civilization that has learned to harness energy in unique ways to survive in its harsh and perpetual night? This theory, although speculative, has opened up an exciting avenue of research for planetary scientists and astronomers. Could the dark side of Proxima B be hiding advanced technology? The idea that Proxima B's dark side could be home to advanced technology is a captivating one. If the emissions detected by the James Webb Space Telescope are indeed artificial in nature, they might point to a civilization that has found a way to thrive in the planet's extreme conditions. The concept of a society living in perpetual darkness is difficult to imagine, but it is not beyond the realm of possibility. Advanced technology could provide solutions to the challenges posed by the planet's harsh environment, such as creating light, heat, and energy in ways that we have not yet conceived. If such a civilization exists, it could have developed technologies far beyond our own, making it one of the most remarkable discoveries in human history.